Welcome back to the Data Science Mentor, where I help you become and grow as a data scientist. This is the final video in this series on getting started with Git and GitHub for data science. And in this video, I will demonstrate how we can use Git to manage and save any work we do using the repository that we created in the previous video. So let's get started. Alright, now in the previous video, we created a repository called COVID-19 Analysis on GitHub, and we cloned it using the SSH option into a directory on desktop called Projects. Now if we navigate into the repository, so let's run cd cov, and one nice feature in terminal is the autocomplete feature. So if the file exists in the current directory and you hit tab, it should autocomplete the name of the file. So watch this, 3, 2, 1 and tab, and it autocompletes the name of the repository. So this is definitely a very handy feature in terminal that I use all the time. And now let's run this to navigate into the repository. And now if we run ls-a to list the contents of the repository, including any hidden files, it should print the README file along with a hidden folder called Git that identifies this directory as a Git repository. Now before we proceed, let's make sure you know and understand a fundamental concept about Git repositories. Now a Git repository is essentially a tree. And when you create a new repository, you start with an empty tree. And every time you save changes to the repository, you create a node in the tree, which is called a commit. Now each commit or node in the tree is identified using a 40-character long unique hash that Git generates using a combination of information, such as the commit message, the author who's making the commit, and the date on which the commit is made. And if we check our repository, COVID-19 Analysis on GitHub, we see that we already have one commit or one node in the repository tree, which is essentially the README file that we decided to initialize the repository with when we created it. GitHub describes that as initial commit. And to access all the nodes in the repository tree or the commits, you click here. And as I already mentioned, so far we have only one commit. And here you can find the first 7 characters of the commit hash. And if you click on it, it should redirect you to a page that has a full description of the commit, like the 40-character long hash and a detailed description of the changes associated with this commit, which in this case are creating the README file and adding the description field to it. And if you wish to access the files associated with this commit or the version of the repository when this commit was made, you can click Browse Files. All right? And each repository has a pointer called head that typically points to the latest version of the repository or the latest commit. And so each time you make a commit, the head simply moves and points to the new commit. And therefore, if you wish to access an older version of the repository or an earlier commit, you simply make the head point to that commit. Understanding and internalizing this fundamental concept helps you a lot, especially in situations where you want to perform advanced Git operations. All right, and now let's go back to terminal. So let's start building our project code. Now to build your project code, you can use any editor or integrated development environment or IDE. My favorite is Atom. If you wish to start using it as well, simply go to atom.io. And it's amazing how it will automatically detect your operating system. So click here to download the disk image or the DMG file. And once it's downloaded, run it to install Atom. Now I'm going to speed it up, but installing it may take a few minutes, so give it some time to install. Alright, now that it's installed, I'll start it. And I really love how I'm able to work continuously in Atom using only keyboard shortcuts without the need to use my mouse or trackpad. So I'll type Command W to close all these welcome tabs. And now let's start by adding the project folder to this window. So I'll type Shift Command O. And the repository is in the projects directory on desktop. So let's navigate to it and select it. And now let's create a subdirectory to house all of our Python scripts. But as you can see, the cursor is blinking in the README file, meaning that the file is what's active. So I'll type Control 0 to switch to the project tree in the left pane, and then type Shift A to create the subdirectory. Let's call it scripts. And now inside the scripts subdirectory, let's create a Python script. So I'll type A to create a new file, and let's name it data_cleaning.py. Now for the sake of demonstration, let's create a list named cases and set it to be the numbers 100, 2000, 4000, and 5000. And Command S to save. So now our local repository has new changes that are highlighted in green here that need to be saved. Note that in Atom, when you create new files in a repository, they will be highlighted in green. Let's switch to terminal. And now if you want to check the status of your repository at any time, you use the Git Status command. So with the changes we made so far, if you run Git Status, the changes should be displayed in red. And untracked files are essentially new files added to the repository. And so what this is telling you here is that there is a new subdirectory called scripts that was added to the repository. Now, the process of saving changes to a repository consists of two main steps: staging the changes and committing the changes. To stage the changes, you run git add followed by the change, which in this case is the script subdirectory. And now if you run git status again, the staged changes should appear in green. Now say after staging the changes, you realize that you made a mistake in the list that you defined, and that this 100 was supposed to actually be 1000. You can easily unstage the changes by running git reset. And now if you run git status, it should confirm that the changes got unstaged by showing them in red again. So let's go ahead and fix the list by changing the 100 to 1000 and type Command S to save. And now you'll switch back to terminal and run git add scripts to stage the changes, and then run git status to confirm that the changes got staged. And to complete the process of saving the changes, we will commit them by running git commit, which requires you to add a message that's descriptive of the changes that you want to save through the M option. So let's add a message that says creates a scripts folder and a Python script to analyze COVID-19 data. And this should print a summary describing the changes that we just saved. So here it is showing that the changes involve just one file and that they were in the form of two insertions into the file. If we deleted any lines from the file, it would display them as well in the form of deletions. And that's it. That's all you have to do to save your work. And with this commit, you just created an additional node in the repository tree. And now head is pointing to this new commit. Okay, let's switch back to Atom and make a couple of changes to the Python script. Let's change the name of the list to total cases. And let's add another list and call it deaths and set it to be the numbers 50, 100, 150, and 200. And we will type Command S to save. And let's create another Python script. So I'll type Control 0 to switch to the project tree, type A, and let's call the script functions.py that will include any global functions that we define to analyze our COVID-19 data. But for the sake of demonstration, let's just add a print statement. So print functions for analyzing COVID-19 data, and type Command S to save. And the README file is most likely feeling left out now, so let's update it as well. So again, I'll type Control 0 to select the project tree, use the down arrow to move to the README file, and hit Enter to select it. And just for the sake of demonstration, let's add the main Python script is data_cleaning.py in the scripts subdirectory. And type Command S to save. And notice the color change. Like before, because the script functions is a new file, then it's in green, but existing files that underwent changes are in orange. And now if we switch back to terminal and run git status, it should show that the existing files, which are the readme file and the Python script data cleaning, were modified. And just like before, under untracked files, a new Python script called functions was created. And if for some reason you're not sure what you have changed in a file, you can easily find out by running git diff, the name of the file. So if you're not sure what changed in the script data cleaning, for example, you can run git diff scripts / data, and I'm going to hit tab to autocomplete, and now run this. And it should print what changed in the script. As you can see here, deletions are printed in red, whereas additions are printed in green. So we're able to tell that the changes were essentially changing the name of the list of cases from cases to total cases, since the elements in both lists are the same, as well as adding a new list of deaths. So git diff is definitely a very useful command to know. Okay, and now to save the changes, like before, we need to complete 2 steps, stage the changes first, and then commit them. To stage them, we will use the git add command. Now, if you wish to stage all the changes in the current directory, you can run git add dot, where the dot means the current directory, which of course includes all of its subdirectories. And since we're in the root directory of our repository, then running this would stage all the changes that we made to the entire repository. So if we run git add dot and then git status, you can see that all 3 files got staged. Now, if you wanted to stage only the changes you made to the script subdirectory, let me unstage the changes first. So git reset. Then to stage the changes you made to the script subdirectory only, one way is to run git add scripts / dot, and this should stage the changes you made to the script subdirectory. Or the other way is to navigate into the script subdirectory. So I'll type Control A to move to the beginning of the command line, and then type Control K to delete it, and then run cd scripts to navigate into the script subdirectory, and then run git add dot. So it's really up to you. But the point here, which is really important, is that you add the path to the file that you wish to stage or commit, starting from your current working directory. So if you wish to stage only the changes made to the script data cleaning, for example, now because we are inside the script subdirectory, you only type the file name. Because if you were to run git add scripts / data_cleaning.py, well, first, if you type data only, for example, and hit tab to autocomplete the name, it won't autocomplete, and you hear this sound, which is a sign that something is not right. And if you insist and run this, you will get an error, and it will complain that it cannot find a Python script called data_cleaning.py in a subdirectory called scripts inside the current working directory, because we are already in the script subdirectory. Okay, so the command to run is git add data, and I'm going to hit tab to autocomplete. So data_cleaning.py. And this should stage the changes made only to this file. And to complete the process of saving the changes we made to the script data cleaning, we use the git commit command. So run git commit. And for the message, let's add fixes name of list of cases and adds a list of deaths. Cool. And now if you run git status, it should show that there is still the README file and the other Python script that was created. Let's work with the other Python script. Let's save it. So we will start by staging it. So let's run git add functions.py and then use the git commit command to complete the process of saving it. And for the message, let's add creates a Python script for global functions. Cool. So far, we staged and committed one file at a time. But you don't necessarily have to save changes this way. You can actually stage multiple files and commit them all using one commit. But the best practice is to stage files that serve the same purpose and commit them together so that you're able to describe the change in the git commit command using one concise message. Cool. And now if you're interested in checking the history of your changes and the commits that you made so far, you can run Git Log, and it will print the repository tree or the history of your commits. Now this log is printed in Vim, and the colon at the bottom here means that there is more content. So you can use the up and down arrows to scroll up and down. So I'll press the down arrow to scroll down, and when it displays end at the bottom, it means that you hit the end of the content. Okay, so as you can see, we have 4 commits so far, including the first one that was created because we decided to initialize our repository with a README file. And each commit is identified using a 40-character long hash. And where it says origin master is the depth of the remote repository tree starting from the bottom. In other words, the remote repository has only one node or commit. And where it says head represents the depth of the local repository tree. In other words, the local repository has 4 nodes or commits, which means that the 2 repositories are out of sync and the local copy is ahead of the remote copy by 3 commits. And because this log is printed in Vim, you quit by simply typing Q. And if you run Git Status, it should confirm that your local copy is ahead of the remote copy by 3 commits. Alright, so to sync both copies, you use the git push command to push the changes you made so far to the remote repository. And if the remote repository has changes that you don't have in the local copy, then you can sync both repositories using the git pull command to pull the latest changes from the remote repository into the local one. So when wanting to push changes to the remote repository, I always recommend pulling first to make sure that your copy of the remote repository is the latest. So run git pull first to confirm that your copy of the remote repository is up to date and didn't change since you cloned it or you last pulled. It should print that it's up to date since we're the only ones working on the repository, but when working with other data scientists and developers, you can't guarantee that. Okay, and now run git push. Cool. And now if you run git log again, you should see that both repositories are in sync. And if you check the remote repository on GitHub, so let me switch to my browser and I'll type Command R to refresh the page. And now you should find the script subdirectory appear on the main page. And inside it, you should find the 2 Python scripts, data cleaning and functions that we created. Also on the main page, you should see 4 commits. And if you click on it, you should find all 4 commits that we made so far. Cool. Let's switch back to terminal and type Q to exit this log file. Now, if your machine wasn't linked to your GitHub account using an SSH key, then when running the git push command, you would have gotten prompted for your GitHub credentials to authenticate yourself. Now, when working on a real project with other data scientists and developers, you would be git pulling and git pushing many times every day. So imagine if you have to type your GitHub credentials every time you want to sync your local repositories with the remote ones on GitHub. It would be super inconvenient. So spending some time to properly set up your GitHub account, like we did in the previous video, is totally worth it. Now, let's say you decided you actually didn't need the Python script functions, and you would like to delete it from the local repository as well as from the remote one. And not just deleting it, but removing it from the entire project history. Because remember, if anything is committed, it will be there forever. Because as we know, commits represent the history of a project at different points in time. So even if we were to delete the script functions now and stage this change and commit it, the script functions would still exist in this commits files, which we can access by simply making the pointer head point to this commit. Therefore, if we want to delete the file from the entire project history, then the simplest way would be to uncommit or delete the commit in which we saved the Python script functions, which is luckily the last commit we made. Now, this is our repository tree. So what you want to do is reset the pointer head to point to the previous commit as if the latest commit never existed. So to do that, you run git reset along with the hard option, so -- hard, And what you want to reset is the pointer head. So you type head, all caps, and then tilde and 1, where 1 means go back 1 commit only. If you want to uncommit the last 2 commits, you would run head tilde 2. And if you want to uncommit the last 3 commits, you would run head tilde 3 and so on. Alright, so let's go ahead and run this to delete the last commit. And this should print a confirmation that head now is at the previous commit, where we fixed the name of the list of cases and we added a list of deaths to the Python script data cleaning. And now, if we switch to Atom, you will find that the script functions doesn't show up in the project tree anymore, which means that it's been deleted. You can still see it here because we had the script open, but if we did not, then it would be gone. Also, because head is now pointing to the previous commit, then when we uncommitted the last commit, it also erased any unsaved changes we made since the previous commit. And so as you can see here, the README file is not in orange anymore. And the line that we added about the main script being data_cleaning.py is gone. Of course, there are other ways for removing files from a commit, especially if the commit you're trying to delete is not the latest one, and if you have other files in a commit that you wish to keep. But this would be advanced Git operations that I'm not going to get into in this video. So for now, be careful when uncommitting changes, and I would say use it with caution. Alright, let's switch back to terminal. And now if you run Git Log, it should print only 3 commits, confirming that the last commit was deleted. But if you run Git Status, it will show that your local copy is behind the remote copy by 1 commit, which means that the remote repository still has the commit that you just deleted. And you can confirm this by going to GitHub, and let's refresh the page to make sure that it's updated. And if you check the commits that you made so far, you will find that the last commit is still there. And if you look in the script subdirectory, you will find that the script functions is still there. So to delete the last commit from the remote repository, we need to push the changes that we just made to the local copy and use the force option. So you would run git push -- force. And now if you run git log, it should show that both repositories are in sync and that the last commit was deleted. And if you check the remote repository on GitHub, let's refresh the page first. You should see only 3 commits, confirming that the last commit we made was deleted from the remote repository as well. And if you look in the script subdirectory, the script functions should be gone. Alright, and this concludes my demonstration on how to get started with Git. We used many Git commands in this video. So in the description below, I will link to a list of the Git commands that we covered, which you can use as a reference until you're comfortable with the different Git commands that we covered in this video. And if you wish to continue using Atom as your IDE, make sure to drag it into your applications folder. And now in the next video on Git and Github, we will cover more advanced topics such as branching, merging, resolving conflicts, and making pull requests. So in this series, I showed you how to properly set up your GitHub account, how to create a repository on GitHub, how to clone it to create a local copy of it, how to check for changes in a repository, how to stage them, and how to commit them. I also demonstrated to you how to unstage changes and how to uncommit them locally as well as on GitHub. And so with this, you should have your GitHub account all set up so you can start creating repositories for your projects and committing and pushing your code and work to your GitHub account to start building your data science profile. Now, if you found this series helpful and educational, and if you think it might help someone else who is aspiring to become a data scientist, please make sure to share it with them. I'll see you next time.